Okay, guys. So let's get started with chapter number 2. This is our first part. Actually, we will have here 4 parts until we finish chapter number 2. It's large a little bit, but it's so important, as I said to you, because starting from this chapter, you will be able to explore the data, find the graphs, calculate the summary statistics. Okay, so we have a lot of graphs, a lot of tools we can use to find or to analyze our data and to find the patterns from the data we have. So first of all, we would like to know what is the different type of data. The data, it's not just numbers. We may have different type than numbers. So first of all, if you remember, our definition for the variable is any characteristics observed in a study. Okay, so this is our or another definition for the variable. Like what? Like the temperature, we have high, low, if it's cloudy or not, if it's raining or not, the number of centimeters of precipitation. Okay, so as you can see here in this example, you may have categorical, or sometimes we call that qualitative data, or quantitative data, or numerical data. So categorical means qualitative, quantitative means numerical or numbers, as you can see here. So these are our two types of variables we have in statistics. This is the general, actually this is the general classification. Okay, actually under each category we can classify them more and more. Okay, but this is the general classification, categorical or quantitative data. Okay, what is the categorical variable or categorical data? As you can see here, we have or we observe groups or categories or labels. Okay, and we can classify these categories by distinct groups or categories. Like what? Like gender, we have male and female. We have the religious affiliation, for example. We have the type of residency. Okay, we have apartment, condo, villa, whatever. Believes in life after death, yes or no. So as you can see here, all these variables have labels. Like gender, we have male and females, just two groups or two categories. Okay, um, believe in life after death, yes or no. So we have just two groups of people. Groups will say yes, and another group will say no. So we have, as you can see here, groups or labels or categories, as you can see. But the quantitative variable, here we have numbers. We have numbers. Like what? Like age. The age is a number. Number of siblings is a number. Annual income is a number. Gas price is a number, right? The weight is a number. The height is a number. Okay? Okay. Some characteristics or features about the quantitative and the quality or categories variable. For the quantitative variables, key features are what? The center and the variability or the spreading of the data. So when you have number, you can find the center of these numbers. You can find how this data is spreading out on the real line. So you can do that. But for the categories, the feature is the relative number of observations in the various categories. Simply the percentage. You can compare between them by just percentages. You cannot find the center. There is no center for the categorical variables, but you can compare between a category and another category by percentage, as you can see here. Okay. We can classify the quantitative variable into discrete and continuous variable. Discrete means the possible value we have is integer numbers or whole numbers like 0, 1, 2, 100, 200, 300, 1000. So you don't have here decimals or fractions. You have just the integer numbers or whole numbers. You don't have any fractions or decimals. So that means you have discrete data or discrete variable. Like what? The number of bits you have, number of children in the family, number of foreign language you can speak, number of cars you have. You cannot say I have 2.5 cars. There is no a half car. You can just say 2, 3, 4, or 0. But so you have just integer numbers. So when you have something like that, that means you are dealing with discrete variable. But if you have decimals or fractions or the variable can take any number in a specific interval, that means we have continuous variable. Like what? Like the height and the weight. We may have, for the height, we have 5 feet. We may have 5.1 feet. We may have 5.5 feet, right? So you have decimals here, okay? The age, also, we consider it continuous. Why? Because sometimes we say I have 40 years. I have 40.5 years, which means 6 months as well. Okay, so you have different numbers, or this variable can take any numbers in interval, a specific interval in this case. Okay. Of course, any time or something like that, or speed or height, whatever. So all these variables are continuous. Okay. The distribution of a variable, and this is what we are interested in statistics when here in the statistics, because the more important thing is to know how your variable distribute in general. Okay. So in this case, you have to find the distribution of your data, and to find the distribution of your data, you have to see it, you have to find it, you have to display it, you have to calculate it. So that means you need graphs so we can display this distribution, and also we need tables to organize this distribution in it. We call this table frequency table. Okay. Before we can talk about the frequency table, we have here a practice about the type of data. As I said to you, we have categorical or quantitative, and if it's a quantitative, we have discrete or continuous data. So let's do this together. The first one, the gender. We have male, female, or others. We have here categorical or quantitative. The gender, male, female, or others. Categorical, yes, so it's a categorical. So we can put here C. So the first one is categorical, okay? Year in college, first year, sophomore, junior, senior. Yes, it's still categorical. Yes, it's categorical. C. Number of children in your family, including you. Yes, it's a quantitative. Discrete or continuous? Discrete, yes. So it's D, discrete. Because here you can say 0, 1, 2, 3, 4, but you cannot say any fractions, right? So it's a discrete. Typical daily soft drink consumptions in ounces. Yes, correct. It's a continuous. Very good. So it's a continuous. CON. College GPA. Hmm. D- Discrete, which means it's quantitative. Huh. Is it okay? Huh. GPA is a number? Yes, it's a number. It's a number. GPA is a number, right? Okay, so it's what? Huh? Discrete or continuous? Why discrete? No, it's not discrete because you may have 3.1, 3.5, 4, so you have decimals, right? So it's what? Continuous. It's not discrete. TON. Okay. Expected grade in this course. Huh? Grade. Expected grade. A, B, C. Huh? So it's what? Huh? Yes, it's categorical. It's not. It's not numerical. Okay, so it's a category. Number of hours you study in 24 hours or a day on average. Number of hours. Number of hours. Number. Yes, it's first of all, it's quantitative. Discrete or continuous? Continuous. Yes. That's a why? Because you can say I study on average 2.5 hours, for example. So you have decimal, right? So it's continuous. Number of hours you use your smartphone in texting, including texting, in a day on average. The whole day, right? Yes, it's still continuous. Number of hours you use. You can say 5 hours, 5.5, 5.3, whatever. Okay. Okay. Annual income you expected to earn in 10 years. Number or number? It's a number. Yes. Continuous or discrete? Huh? Discrete? Continuous, right? Continuous. Yes. CON. Continuous. It's continuous because you can say, for example, this is just an example, okay? You can say 10,000. You can say 10,500, right? You can say 11,000, right? So we have here all numbers we can put here, okay? The height in inches. Yes. Quantitative, huh? Discrete or continuous? Continuous. That's right. Ah, favorite. Whole number from 1 to 10. Quantitative. Discrete. Yes. Quantitative, discrete. Yep. So it's D. Last one. Ignore European. It's a shoe shoe size in general. Huh. Shoe size. Is it a number? It's a number. Okay. Discrete or continuous? Huh. Continuous, because you may have decimals, right? 10.5, 9.5, So we have continuous. Okay? Okay. So let's talk about the frequency table. As I said to you, in this table, we summarize our data. And from this table, we can find the distribution of our data. Okay, but let's talk about what is the frequency table. So as you can see here, it's a listing of possible values for a variable together with a number of observations and or relative frequency for each value. In our example here, we have or we talk about the frequency of shark attack in various regions from 2004 to 2013. These regions are Florida, Hawaii, South Carolina, California, North Carolina, Australia, South Africa. As you can see here, we have regions. Okay? And the frequency, this is the second column. So what is the frequency here? What that mean? When we say 203 and by Florida here, what that means? 203 what? What is 203 here? Yes, 203 shark attack happened in Florida from 2004 to 2013. Correct? Okay, same thing. 51 shark attacks happened in Hawaii from 2004 to 2013. So this is the frequency, as you can see. Okay, so of course, if you try to imagine what was the raw data in this case, what was that? Okay, so that means the raw data was 230 times Florida mentioned in the raw data, and 51 times Hawaii mentioned in the raw data, and 43 times South Carolina mentioned in the raw data. But when we start to put them in our frequency table, of course, it was huge, right? It was large table. Now we summarize these data in just this frequency table, as you can see, based on the region, as you can see. So it's better than what we have before. From the frequency, we can find the proportion, or sometimes we call it the relative frequency or the proportion. Okay, how we can find it? So simple. For example, the first proportion here for Florida is, as you can see here, it's 0.295. How we can find this proportion? So easy. First of all, you have to find the total of frequencies. As you can see here down there, you have the total, 689. This is the total shark attacks happens on all these regions, okay? And then you start to divide each frequency for each region by the total frequencies. So for the first proportion we have here is 203 divided by 689. So it's give us this proportion. Same thing for South Carolina. You have 34 divided by 689, give us 0.049, and so on. So this is the way we can find the relative frequency or the proportion. Okay? And then you can find the percentage for each region. Okay? So how? Just to multiply the proportion by 100. So you have the percentage. Okay? So the percentage is sometimes, and the proportion, of course, give you more information than the frequency, right? Because you can see here, 29, we have 0.5, say 30% approximately. 30% of shark attack happened in Florida, right? You can see that from the table, okay? 7.4% of shark attack from 2004 to 2003 happened in Hawaii, right? So it's more informative than the frequency or the number, the count we have here, right? Okay. So of course, in this slide, I show you here how to find the proportion or the relative frequency and the percentage, in general, okay? And here you have an example for Florida, how you can find the frequency and the percentage, as you can see, the relative frequency and the percentage, as you can see, okay? As I show you on the table. Okay. Suppose we have discrete quantitative variable. Okay. No, sorry. No, no, this is not correct. This variable is categorical. It's not discrete quantitative. So I will correct the title. The title is not correct. This one is categorical. It's not uh, quantitative. So this one is categorical. It's a categorical variable. It's not quantitative. Okay. So suppose you have categorical data and you want to describe or to construct the frequency table in this case. So easy. First of all, you have to have the raw data. As you can see here in this example, we have the variable about the type of emphasia. We have three types. We have raucous, anemic, anomic, and conduction. And we have the data in this table as you can see here. Okay, the type of emphasia and the subjects. The subjects means the maybe a patient who has any type of these three type of emphasia. Okay, so you can find the frequency table for this type of data by this way. First of all, you have to know how many categories you have here. Here we have three types of emphasia, so that means you have three categories. So first, start with the type, as you can see here. The type of emphasia, anomics, raucous, and the conduction. Okay, and then we start to find the frequency of each type we have here. As I said, the frequency means the number of patients or people who has anomic, for example, or raucous or conduction. So start to count how many anomic type in the raw data. So you have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the frequency is 10. What about Procus? How many in our sample here? So we have Procus, we have 1, 2, 3, 4, and 5. So the frequency is 5. Okay, what about conduction? So the conduction here we have 1, 2, 3, 4, 5, 6, 7. So we have 7. Okay, so you have the frequency now. And you already know how to find the proportion and then the percentage, as you can see. This is a small example because the sample here is just 22 subjects. What if you have 1,000 or even 50? Okay, 100. So this will take time until you find this table. So this is the rule or the benefits of the statistical software. Give them the raw data and they will give you the frequency table directly. Okay, so our example for today, we will use today Excel to find the frequency table for a categorical data. Okay, so as you can see here, you will know some functions in Excel. The first function, you have this one, count. You have countF. This is the function in Excel, and you will know now what is how we can use this function to find the frequency for a categorical data. And as you can see here, you can do some math operations like the division, the multiplication, okay? And also you have a nice tool for copying and pasting the function. So that means you will do the function just one time and copy and paste it to the other cells. So you don't need to repeat the function each time. Just you will do it one time, and after that you can copy it, copy and paste it. So you will have the entire uh, table. Okay. So let me share with you the Excel sheet we have. You already have this Excel sheet on the blackboard. Okay. So as you can see, we have our raw data in the first column, as you can see, the type of aphasia, and you have the data. Okay. So first, you have to find the classes or the type of aphasia, as you can see here, in any empty cell. Okay. Here I start with D2. Okay. So you have anomic, fracus, and the conduction. I wrote them by myself. Okay. And then I need to find the frequency. Okay. Of course, this is a small example, but so imagine you have 1,000 patient or subjects in this case. Okay. So always in Excel, you equal sign, the equal sign to start the function, the equal sign. So all functions in Excel start with equal sign. Okay, and then start to write your function. So as I said to you, the first function is count f, count f. So just you start to type the function, you have a small menu, as you can see here, start to display all functions start with C, and after that, when you type O, you start to find this all function with CO, and then, okay, so just you start to see OU, for example, you have all functions started with COU, which of course you can continue, but that's enough. So you have count TA, or count A, count blank, count F, count S. You have a lot of functions here. But as I said to you, you will use count F function. So just click on it. And you have here what we need to complete this function. Here you need two things: the range of your data and the criteria here. What is the name, or what is the group you wanted to count? What is the name or the group you wanted to count? This is the criteria. So if you go to the first column, A here, as you can see, my mouse here, it changed it from this plus to this small row. Okay, goes down. Okay, and then click on the row. As you can see here, the functions selected A to A, which means we select all the data in the first column. A to A means we select all the data in the first column. And then comma, okay, in this column, you wanted to count what? You wanted to count anomic, right? So simply click on anomic here. Of course, it will give you D3. Anomic here is D3. Okay, this D3 is the name of the cell that we clicked on anomic here, as you can see. And then close the parenthesis and then enter. So you have the number of anomic we have in our first column, as you can see. Okay. Something nice about Excel is to copy and paste the function. You don't need to write it every time. Just copy and paste them. How? So easy. Look at this square. Do you see it? Okay. there is a small square down there. Look, when I try to my mouse change from white plus to black plus, small black plus, as you can see here. Okay, so just you have this, that means you are ready to copy and paste the function to the other cells. Okay, but first you have to step on your function and then go to this small square there and then click, still hold, and then go and copy this function to the other cells. So as you can see here, you have 5 and 7. Okay, so that means if you have, for example, 20 categories, you can just type the function one time for the first one and then copy and paste this function to the other cells so you have the frequency quickly, as you can see here. Okay, how we can find the proportion? To find the proportions, you need to find the total. Okay, so the function for the total, you don't have it here, but it's sum function. Okay, sum function. So the second function you need here is sum function. So start with equal sum, open the parentheses, and then select the cells you want to find the sum to it, like this, and then enter. So you have the sum, as you can see, 22. Would like to find the proportion for each category. Okay, so on this cell, start with equal again. We can find the proportion by dividing each frequency by the total frequency. Here you have two options. The first option is to do this one. To click on 10, of course, it will give you E3. This is the name of the cell with 10 in it. Okay, divided by 22, like this. So you have E6. Okay, this one will be correct, as you can see here. You have a number, right? But look, if you try to copy and paste it, look what will happen. Wrong numbers, or there is no division actually. Why? Because what happened here, look at this one, actually the function up there here. What happened? It's divided E4 by E7, and the E7 is empty. So what happened here? When you copy and paste the functions, the name of the cells change based on the direction you go, down or left, right or up. Okay, so you have to make sure that you divide by a constant cell. So how you can make a cell constant, or sometimes we call it, you lock the cell, which means you prevent it to move when you copy the cell from cell to another cell. Okay, so how you can do that? So let me just clear this one, and I will return it to our equation there. Which cell you would to lock? Which one? It's E6, which has 22. To lock this cell, all you need is to go before E here and add $sign. This lock the column, okay? And you wanted to lock the row that contains 22. So you will go before 6 and lock it by $sign. Okay? So as I said to you, first one, there is no problem. Still okay. Return again to the function we have, and then start to copy and paste it to the other cells. Look, you have the numbers now. Why? Because Each one of them, as you can see here, is divided by the same locked cell, 22 or E6. So in Excel, if you wanted to prevent any cell to move when you copy the functions, you need to lock it. How to lock the cell? By adding the $sign before the row name or the column name. Of course, our names here is A, B, C, D. This is for the columns, and the 1, 2, 3, 4, 5. These are for the rows. Okay. After that, you find the percentages. How? As you can see, we are and know all you need to multiply the proportion by 100. So it's equal to the proportion we have here times 100, like this. So you will have the percentage. Return to this function again and start to copy it to the other cells. Go all the way down. Okay, so you have the percentage. Okay, someone can say that why we have a lot of decimals after the decimal point. We have a lot of numbers here. How we can decrease these numbers? Okay, so easy. Select these numbers, as you can see here. I will highlight them, and then you have which one? This icon. Do you see this icon up there? Okay, look. Here you increase the numbers. The other one is decrease the number of decimals after the decimal point, as you can see here. So you can control with the size of the numbers after the decimal point by increasing or decreasing the number of digits, as you can see here. Okay, okay. And of course, you can move the or adjust the width of the columns by this way, as you can see here. Okay. Also, you can add the percentage simple way to find the percentage by Excel like that. Is to copy the same numbers to the percentage like this equal this. So you have the same numbers, copy them there, and add the percentage simple like this. Okay, and of course you can again add and some digits after the decimal point. Okay, as you can see here. Okay, this is the second way to find the percentage in Excel.